Going on now to topic 4 of chapter 1, properties of real numbers and algebraic expressions. Again, all this is meant to be background for when we do equations and later graphing. We want to be familiar with the vocabulary. So we said in section 2, we use the symbol equal to mean is equal to. Here are some other words that often are translated into the equal sign. Equals, gives, it, was, yields, represents, amounts to, is the same as, is equal to. Okay, so let's do a little bit of translation. And by the way, we will be covering these objectives in this section. Write each sentence as an equation. Now the sum, and this is kind of critical here as we go about these things. How do you indicate a sum? Well, it's going to have a plus sign. And in some cases we have to put parentheses around to indicate that that's a sum. But here it's clear. There's no necessary qualifier or anything. It's just the sum of x and 5 equals 20. Now here's where we do need a parenthesis. 2 times the sum. So we have to indicate that this is a sum by putting parentheses around it. The sum of 3 and y. So the n is the plus sign. Amounts to equals 4. Now the difference of 8 and x. 8 minus x. That would be the difference. And in a way this is a sum as well, although it's subtraction. Is the same as the product of 2 and x. Now when they say product, that implies multiplication. So we can write it 2 multiplied, that dot up in the center, x, or just plain 2x. This is another very common one, but again you have to know what the word quotient means. It means a fraction, a ratio, that this is divided by this when they say quotient. So we usually write it z, that's the first item, over the 9, amounts to 9 plus z. And you'll have practice on it, and there are some more. Now the other symbol we want to quickly mention is when you have an equal sign with a slash through it, this means is not equal to. Other signs that we'll use are inequality signs, where it points to the point is toward the left. This is a less than sign. If the point is to the right, this is a greater than, and we're reading it in this direction. So less than, the point is to the left. Greater than, the point is to the right. And on a number line basically is anything to the right of something is greater than to the left of something. So here we would say A here is less than B, and B is greater than A. Well, I think I've discovered an error in the textbook, and this can happen, not often, but every once in a while. I probably should write the authors. So they have this in the incorrect way here. All right, let's go on. So in example 5, we see they are asking us to insert these symbols in these examples to see or to make them true statements. So -1, -2, which is the larger? Well, this is actually on the right, this is on the left. So -1 is greater than -2. Now, when we do this division, 12 divided by 4 is 3. So here we're going to have an equal sign. 3 equals 3. Now, 0 on the number line is to the right of where -5 is. So -5 is less than 0. Now again, something to the right. This is actually on the right. So this is to the left of it, so it would be less than. Now, when they're positive numbers and fractions and the denominators are the same, that's sort of easy to compare because we see our numerator here is larger, so there's more positive here, so this is greater. Now, when they're different fractions, you might need to use that technique of getting the denominators the same. Common denominator here would be 12, and we'd multiply this by a 1 in the form of 4/4. So this one would be 8, multiplying this by 4, multiplying this by 4. 4/4 is 1, so this is 8. Now, to make this a 12, we're multiplying this by 3/3, so this would be 9. So when comparing then these fractions, this one is the smaller. So we would say 2/3 is less than 3/4. And as you look at your textbook, they give you not only a visual, but a more complete explanation. Now, we just went over these symbols, less than, greater than. A modification of this is when we add an equal sign to it. This is less than or equal to. This is greater than or equal to. Now, when we use these inequality signs, in order for it to be true, just part of it needs to be true. And we'll give you some answers here, or some examples. So we'll get to this shortly, but let's take a look at it. 3 is less than or equal to 5. Is this a true statement? Well, we know it doesn't equal 5, but the 3 is less than 5, so we count this as true. Now, how about 7 is greater than or equal to 7? Well, we know they're equal, but it's not greater. One part of it is true, so this would be true. Now, if you had 6 is greater or equal to 7, neither part is true, so this would be false. Now, in example 6, they ask us to write these statements. So let's write them. The sum of 5 and y, the sum of 5 and y is greater than or equal to, greater than or equal to 7. 11 is not equal to z. 11 is not equal to z. 20 is less than the difference of 5 and twice x. So the difference indicates subtraction, the difference of 5, and twice x. So twice x minus 5. Now, in looking at letter C more carefully, here I think order is significant, so I think you would have to write it 5 minus 2x, the difference of 5 and twice x. You'll see in a little while that this is not commutative. Subtraction is not commutative. You can't just switch these two around. So here it's saying the difference of 5 and twice x. I think that's what they're looking for. And as we look at the solutions, we see it is in that order. Now, if it was addition, it wouldn't make any difference. But subtraction, it does. Okay, that's a little tricky. All right, now what we're going to do is take a look at identifying identities and inverse. So now we're looking at some of the properties of mathematics. Now, as you read this, they say that 0 and 1 are very interesting numbers. You can add 0 to anything, and it doesn't change its value. So we say adding 0 to any number is the additive identity. Now, 1 is interesting also. If you multiply anything by 1, it doesn't change its value. So we call multiplying by 1 the multiplicative identity. So these are two properties that we will be using. In fact, we used this one already when we were making fractions, and we wanted to have, let's say, a denominator of 9. That would be our common denominator, and one of the fractions was 2/3. How did we make that into an equivalent fraction? And we said the technique was to multiply anything by 1, but the form of 1 in this case would be 3/3. See, there's your 1, and then this becomes 6/9. So these fractions are equivalent. This one has just been simplified because here you're taking out a common 3, that is factoring out or canceling out, and you get this. Okay, so we use that. Now, another very commonly used property, and we mentioned this earlier, what do we add, let's say, on a number line? To a 1 to make it a 0? Well, we said it's opposite, which is a -1. Well, another way of describing this is the additive inverse. It's what we add to something to make it a 0. Okay? That's the additive inverse. Now, another property is if we had, let's say, 2/3, what would we multiply the 2/3 by in order to get a 1, a positive 1? And you might say, well, we could just take it and flip it and go 3/2. You may have recalled that. Well, what is the relationship between 2/3 and 3/2? Well, we say that 3/2 is the reciprocal, there's the word, of 2/3. And when you multiply a number by its reciprocal, the product is always a positive 1. And this is what we call the multiplicative inverse. And it's sometimes called the reciprocal. Multiplying something by the reciprocal, or the multiplicative inverse, is what we illustrated here, always results in a positive 1. So there are 2 more rules or properties. So for these, what is the additive inverse first, or opposite? Well, if it's a positive 4, it'll be a negative 4. If it's a positive 3/7, it will be a negative 3/7. If it's a negative this, it will be a positive 11.2. Okay? So it's nice to have some easy things. Now here they're asking for the multiplicative inverse, or the reciprocal. It's what you would multiply this to make it a 1. Now remember, every number is over 1, so the reciprocal of this is 1 over 11. Now this is a negative 9 over 1, so a negative 9 over 1. Now, to get it to be a positive 1, we have to use the same sign. So a negative, and then take and flip this, negative 1/9, so that gives you a 1. So here's a little bit tricky, where if it's a negative number and you want the reciprocal of it, it has to be negative. Like signs give you a positive. And here we're going to multiply this by 4 over 7. Okay. Now for these, again, you should be taking notes on this, in which we're going to use the commutative, the associative, and then later the distributive properties. Well, for the commutative property, we say that A plus B, this is a sum, equals B plus A. That is, we can just take the letters and reverse them, and this is true. This is the commutative property of addition. Now it's also true for multiplication. AB equals BA. So, commutative property, just switch the order around. Now, for the associative, we have A plus B plus C equals A plus B plus C. And we know those are just identities. But for the commutative property now, we're saying we could group A and B together and then add C, or we can group B and C together and then add A. So in the associative property, the order is the same. They're just grouped or associated differently. And this is true for multiplication too. A, B, C equals A, B, C. We multiply AB first, then multiply it by C. Here we multiply BC first, then multiplied by A. Notice the order is the same. But this gives us the right, through properties of mathematics, to do the things we do. And looking at your textbook, you see a summation of what I just did. Now for chapter 1 still, example 9, use the commutative property of addition to write an expression equivalent. So there's that, and we just switch them around, just the order. Now for example 10, use the associative property of multiplication to write an equivalent of this. So again, we're just shifting where we put the parentheses. The order is the same. But now they're asking us to do something here. This is critical. They're asking us to simplify the expression. So we associated these differently. We're multiplying the 4 times 9, getting the 36y. So this is in its simplified form. We did what they asked by regrouping using our parenthesis. Order was the same, and then we simplified. Now, a property we're going to use quite a bit is when we have something like this. A times, in parentheses, B plus C. And we're then going to distribute the factor that's outside to the terms that are inside here. And we can indicate that by like a little line. So A times B is AB. A times C, and we need to put our plus sign, is AC. And this would hold true if it were subtraction in the parentheses as well. This sign would be negative. Now, an interesting thing that we should note about this is now we have A times B and A times C. There's a common factor in each of these terms. So we can sometimes reverse this process by going from this into its factored form. Going this way is distribution. Reversing it, we call that factoring. Out the common factor A. We're going to use that technique in Chapter 2. All right, so what's that process called? The distributive property. So let's use it. And we can have some room right here. So this will be 6x plus 3y. Now here we note an interesting thing. When there's a negative in front of a parenthesis like this, we can think of a -1 there, and we just distribute that, which in essence just changes the sign. So this becomes a -3x, and then this will become a +1. This is a technique also useful in later sections, where we're going to factor out a -1 from this, and basically it just changes the signs, and we need that -1 outside. So here we're going to get a 0.7 AB, and then minus 2 times 7 is 14, but we need 1 decimal place, and then A. And again, looking at your text, they show in the solution area all of this in detail. Now, we worked on this earlier as well, writing algebraic expressions, looking for keywords that will translate into symbols and things. So let's work on some of this. A vending machine contains X number of quarters. Write an expression for the value of the quarters. Well, we know X is the number of quarters. And what's each quarter worth? Well, 0.25 cents. So this is how you would write letter A. the number of grams of fat in X pieces of bread if each piece of bread contains 2 grams of fat. Well, here's your number of pieces, and each contain 2 grams of fat. So there's letter B. The cost of X desk if each desk cost this much. Well, this is the cost of one desk. So if you multiply it by 156, that would be your total cost of all the desks. This is the number of desks. This is what each one cost. The sales tax on a purchase of X dollars if the rate is 9%. Well, you have X dollars, and it's 0.09 cents on each dollar. This would be the amount of tax. And once again, the solution found in the textbook helps you in some detail to read through this. Going on to example 13, write each as an algebraic expression. 2 numbers have the sum of 20. If one number is X, represent the other number as an expression of X. Well, for this type of problem, I often suggest you make a little box. And this box contains 20. And you're saying you want to divide this 20 into 2 parts. So we'll divide the box into 2 parts. Now they're saying one of the parts of this 20 is X. Now using X, how can I represent the other portion, this part down here? Well, if the whole box is 20, and this part is X already, if I subtract X from this, that would be the other part. And if I add these up, the X's cancel out and the whole thing is 20. Now, if the number was, let's say, 800, how would you divide 800 into 2 parts? Well, we're saying part of this is X, and again, the whole box is 800, and if we subtract the upper part that we took away, then that's the other part. And this is the pattern for solving this type of expression. Later we're going to say that this equals something and then solve it as an equation. Now in example B, the older sister is 8 years older than her younger sister. If the age of the younger sister is X, so here we have the younger sister as X. Well, the older sister is 8 years older than this young lady. So it will be X plus 8 as a sum. So this is the younger sister. The older sister is 8 years older. So the younger sister's age plus 8. So if this were like, say, 12, then the older sister would be 20. And this is a way to represent words as an algebraic expression. Now in letter C, they're giving us what are called complementary angles. Angles are complementary if their sum is 90. So here they're saying one angle is x, how would you represent the other angle? Well, if all of this is 90, it would be 90 minus x. And a sister of this one is supplementary angles, which are 180. And if x is one of those angles, what would be the other one? Well, 180 minus x. Now here, if x is the first of two consecutive integers, represent the second integer as an expression of x. So I'll give you a little lesson on this. This is kind of useful. Here we have some integers, 5, 6, 7. If this is the first integer and it's x, how do we represent the second integer, consecutive integer? Well, it would be x plus 1. And the third, x plus 2. Now, a modification of this will be even integers, such as 6, 8, 10. If x is the first even, how do I represent the next even? X plus 2. The next one, x plus 4. Now, how about odd integers? Consecutive odd integers. 7, 9, 11. We're defining 7 as our first odd integer. How do we represent the next odd integer? Well, how many do we have to add to 7 to make it 9? 2. X plus 2. And then how many to 7 to get 11? X plus 4. And you might say, well, wait a minute. This and this are the same. Now, the key to it is what you define as your first integer. If your first integer is even, you add 2 to get the next even. Here, if your first integer is odd, by adding 2, you get the next odd. And then the algebra takes care of it. This is the wonder of algebra here. Okay. Now, as we move to our last objective, simplifying algebraic expressions, we do so by removing grouping symbols and combining any like terms. Now, we need to then define what is a term. We already mentioned what is an expression. But terms are distinguished by separating them in an expression by either a negative sign or a positive sign. So in this expression, there are two terms. In this expression, there are three terms. Now, what is a like term? Well, if you have 2x, y, and a 3xy, that the variable portion of these are the same, and the exponents to which they're raised are the same, then they are like terms. So we'd have something like this, as these are like terms. Now if you had something like this, 2x y to the second, 3x to the second y, you might say they have the same variables, but the exponents are different. These are not like terms. And if you had something like this, 2ab and a 4BA, again, we are allowed to reverse the order of the letters, but they both have the exponent 1, so these are like terms. So we usually say the variable part has to be the same. Order's not significant, but the letters have to be present and the same exponents. And we do that, combine like terms. So one of the things we might do is to identify our like terms. Now, if we did it this way, this is the theory behind it. There is, in a sense there, we can factor out the x, and we have 3 minus 5, and then this becomes a negative 2x. So we have combined like terms, and of course we would need the 4 in our final answer. Now here, yz, and we would put a 1 there, which is not written by convention, but to help us, then the only thing we deal with is the numerical coefficient of that, which is the 7 and the 1, which gives us 8xy. Now here there are no like terms, so this is as far as you can go. And doing this, there's a 1 there, so this would be a 7ab. Here we have a 4x and a 6x. We only deal with the number part of the variable. That would give us a 10x minus 5, and here there wouldn't be any like terms. Now, in looking at example 15, letter A, we see this is a like term, this is a like term, this is a like term. And you could put the 1 there. Now what I'm suggesting, now you could just do it horizontally, but I suggest lining it up in a like term column. So you get all your like terms in like term columns, and then here this is going to be a 4 minus 2 is 2xy. And here there's a negative 7 and a positive 5. This will be a negative 2. Now in letter B, we have to get it out of the parentheses here. So let's do that. So we're just writing these two there, but now we're going to distribute as we take it out of the parenthesis. This becomes a negative 5x squared, and then negative 5 times negative 4 is a positive 20. Now we could put these in like term columns, but again, if you can do it mentally, 7 minus 5 will be 2x squared, and then 3 plus 20 plus 23. And that's basically what they did here as well. Now for letter C, here we have two terms. Let's put it over here. 2.1x minus 5.6. Now here we have a negative in front of a parenthesis, so we're going to multiply through by a negative 1 that just changes these signs. So this is going to become a positive 1x that I'm going to put right there. And this becomes a positive 5.3. Now that I have the right signs and no parentheses and lined up in like term columns, I'm just going to add that. So this is 3.1x. And, you know, this is a little weird, but you're going to subtract the 3 from the 6 and get 3, and the 5 from the 5 and get 0, and the larger absolute value sign is negative. So going back to an earlier part, that technique results in a negative 0.03. Again, I like this technique, but you don't need to use it particularly. Now we can use what they have written up because they have it done nicely here. So we're going to distribute. So 1/2 of 4a is 2a. 1/2 of a negative 6b is a negative 3b. And as we distribute here, a negative 1/3 of 9a is a negative 3a. A negative 1/3 of a positive 12b is a negative 4b. And then a negative 1/3 of a negative 1 is a positive 1/3. Well, here we have like terms. These are like terms. And then we have to add 1/3 plus 1/4. Common denominator is 12. Going to multiply this by a 1 in the form of 4 over 4. This one, a 1 in the form of 3 over 3. So this gives us 4 plus 3, which is 7/12. And a 2a and a negative 3a give me a negative 1a. We don't write the 1. A negative 3b and a negative 4b gives us a negative 7b. And there's our answer. It just took a while to get there. Now, we don't normally get to look at these, but this is cute here, what we see here. Where is the error? Well, we got the x, that part is right. We got negative 4 times x, a negative 4. But notice what happened. They went negative 4 times negative 5. And instead of getting a positive 20, they got a negative 20. And of course, that's where they went wrong. Now, again, in your textbook, at the end of each section, there's lots of vocabulary, reading, and review. But we'll leave that up to you, and we'll finish this.